So we're going to use what we just learned about the intermediate value theorem to look at this example. So it says show using the intermediate value theorem that the square root of x plus the square root of x plus 2 equals 3 has a solution. Okay, so we're going to think about this. Let's get this set equal to 0. So because if we wanted to solve this, we could rewrite this as the square root of x plus the square root of x plus 2 minus 3 equals 0. And recall when we're looking at a function, f of x equals 0, these are the values of x which set this function equal to 0. And so we're gonna, let's call f of x. F of x is going to equal the square root of x plus the square root of x plus 2 minus 3. So we want to show that this is crossing the x-axis at least once. It has a solution. And so we need to figure out some values that we can plug in here for x that would give us some positive number and some negative number. And that would show me that there was a solution somewhere. We have to also think about, though, our domain, because we have radicals here and we can't just plug any number in for x. And so if we look at our domain, what's underneath the radical has to be greater than or equal to 0. But we have two separate radicals, so we're looking at what they both have in common, and that's what we're going to choose our domain. So we need x plus 2 to be greater than or equal to 0. If I solve for x for this inequality, x is greater than or equal to negative 2. But if I look at what they both have in common, it's from 0 to an infinity. So my domain for this function f of x is our x values from 0 to infinity. And so let's look at what happened if we plug in some value 0. We plug in 0 for x because that is in our domain, so we can do that. So if we go in here and we plug in 0 wherever we see an x in our function f of x, we would have f of 0 is equal to the square root of 0 plus the square root of 0 plus 2, and then minus 3. Well, square root of 0 is 0. And then we have the square root of 2 minus 3. So I'm really more curious, is this a positive or a negative number? So I'm kind of thinking to myself, oh, well, what is square root of 2 about? Well, square root of 2, I would think about what can I take a square root of a number? I can take a square root of 1 and square root of 4. 2 is between 1 and 4, so that has to be 1 point something. And so I know this in here is a negative number. I can use a calculator and I can figure out what that number is, but I just want to know the sign. Okay, well, let's try to figure out some number that is bigger than 0, that's in our domain, that might give us back a positive number. And so maybe we can try when x is equal to, let's maybe say 7, because I know what 7 plus 2 is square root of 9. So let me say 7. So let's go back into our function and plug in 7 wherever we see an x. So when we do this, we get this is equal to the square root of 7 plus the square root of 7 plus 2, and then minus 3. And so simplifying this, I get the square root of 7 plus the square root of 9 minus 3. Well, square root of 9 is 3 minus this 3 is 0. So this is square root of 7. This is equal to a positive number. And so by the intermediate value theorem, because those are opposite signs, there has to be some value in between 0 and 7 that crosses the x-axis. So we found, and it's at least one, so we found that this has a solution. We could narrow it down. We could start choosing x's, getting closer to 0 until they don't change signs anymore. Okay, so there is a solution. Where C is between or contained in the interval, I'm going to say 0, 7, such that if I plug in that number C in for x, we would get back 0.
And why would you pick 7? Was that just because you're trying to find any number that would be comparable?
What I was trying to find was actually a number that would give me a positive number, because I know when I plugged in 0 here, I got a negative number back. And so I know that this was below the x-axis. And in order for it to have a solution, I need something that would fall above the x-axis. That would give me a positive number back. And so looking at this -3 here, I thought to myself, okay, I just need to choose some value of x that would be greater than 3 when I subtract it off, and that would give me a positive number. So that's why I chose 7, but I'm wondering, like 4 might work, because the square root of 4 is 2, right? Plus the square root of 4 plus 2 is square root of 6 minus 3. And so if I look at that, the next was, what did I just say? 4. I think that's a positive number, because square root of 6 is a number between 2, 4, and 9. That is a number between 4 and 9, which square root of 4 is square root of 9, 2 and 3. So 2 plus something between 2 and 3 would be a positive number. So I've even sandwiched it down further that there is a 0, but I wanted just something that would give me a y value that was a positive number, and that's why I chose 7. I could have, like I said, I could have chosen any number that would give me some y value that was positive. And by that theorem, and knowing that that function is continuous everywhere on the domain, I knew that that theorem would tell me there was a solution there.